Thank you for your attention to a topic that should be of great concern to us all. Solutions to PET plastic pollution. My name is Rick Tabor, and I'm Principal Polymer Scientist at Tabor Polyurethane Consulting, a small consulting firm dedicated to providing solutions to polymer problems. To understand where we are today, it's important to understand the path that we've taken, so I'd like to start at the beginning. The first patent that mentions the synthesis of polyethylene terephthalate, better known as PET, was issued in Great Britain in 1941 to Calico Printers Association. The short document details how the inventors put ethylene glycol and terephthalic acid together, and with a great deal of heat and time, they were able to produce a polymer with a melting point of 254 degrees centigrade and having, quote, good cold drawing properties. Today, we oxidize cheap and abundantly available paraxylene from petroleum sources to form terephthalic acid. Ethylene glycol is produced in the following manner. Ethylene, also cheap and abundantly available from petroleum, is oxidized in the presence of oxygen or air and a silver oxide catalyst. Ethylene glycol is then produced by the hydrolysis of ethylene oxide with water under pressure. Both of these processes are conducted on a massive scale, giving the lowest possible economics for the monomers. Dimethyl terephthalate may be obtained via the esterification of terephthalic acid, and the use of this monomer in place of terephthalic acid has certain processing benefits. The aromatic diacid and ethylene glycol are polymerized in the presence of an antimony oxide catalyst at high temperature to yield polyethylene terephthalate having a molecular weight that typically ranges between 10,000 and 50,000 Daltons. In the year 2016, this versatile polymer was produced at a rate of 123 billion pounds per year, which is almost incomprehensible to me personally. The photo at the bottom shows a relatively new Indorama PET production facility in Decatur, Alabama. PET is an incredibly useful material that has improved the state of humanity. It keeps our food fresh and allows for lightweight packaging that allows products to be shipped cheaply with reduced greenhouse gas emissions. It is used to package medical devices and keep them sanitary. It is used to construct medical devices, fabrics, and threads. PET is under our bare feet on our carpet as we walk across the room. It makes up the fibers in our clothing, keeps us warm, and wicks water away when we sweat. It is used to keep us comfortable in the form of fiber-filled pillows and furniture cushions. It's used to make films for electronic and oxygen barrier applications. There is no question that PET is a fantastic plastic that has made our lives better in many ways. Unfortunately, because of the low cost, easy availability, and sheer abundance of petroleum, it has been easy for people to dispose of our used plastics, including PET. Too often, PET is sent directly to landfills, and because this is more convenient and cheaper to do, we don't recycle it as often as we should. Our short-sightedness has created a linear economy, which has resulted in a plastic pollution crisis. Microplastics and plastic pollution is being transported by the atmosphere and the oceans to all parts of the globe, from the deepest depths of our oceans to the highest peaks of our mountains, even to the extent that we are actually eating and drinking these microplastics. Today, the trend is for governments to ban single-use plastics such as plastic straws, plates, utensils, and grocery bags. Plastics have collected as swirling gyres, otherwise known as immense floating landfills, in our oceans. Plastics are being mistaken by marine and other animals as food with deadly consequence. To add to the problem, it has been found that in developing countries where there is little access to municipal waste facilities, people simply use nearby rivers as a means of conveying their trash away from where they live. The result is that the vast majority of plastic pollution in our oceans originates from some of the largest rivers in Africa and Asia. These rivers are shown here in a 2017 study by Christian Smith in Environmental Science and Technology. Tragically, mankind seems to have a bad habit of defaulting to the cheapest and easiest solutions to our problems. Now that I have outlined the crisis that we're facing, let's talk about the solutions to PET plastic pollution, which involves moving away from a linear economy and towards a circular economy. In a circular economy, of course, instead of disposing of PET in the cheapest, most convenient fashion, we invest in methods for recycling it and reusing it. We should all be familiar with what's referred to as mechanical recycling, which involves the collection of PET either via municipal curbside collection or via deposit incentivized collection of bottles at grocery stores, like we have here in Michigan. In mechanical recycling, the collected bottles, including the attached labels, adhesive, and polyolefin lids, are first sorted to remove plastic and paper and other obvious contaminants on the conveyor belts. Then the bottles are crushed and strapped into bales for easy shipping to processing centers. At the processing center, the bales are cut open again, and a process of manual sorting occurs again to remove major contaminants. This begins a long process of purification for the valuable PET resource. After sorting, the bottles go through a label removal process, then a metal removal process, and then the bottles are ground into flakes. These flakes are run through a flotation step in water where the PET sinks to the bottom and the polyolefins rise to the top. Both are recycled in separate streams. Next, the PET flakes are washed with a detergent in a hot washing machine, rinsed and dried in a dryer. The clean flakes are then re-extruded into pellets via high-temperature extrusion through a set of stainless steel filters, which further removes any particulates that are not part of the PET. The high-temperature processing in the extruder has the added benefit of sterilizing the resulting recycled polymer, which can now be used to make new bottles or fibers or film. Although the study represented by the graph on this slide was conducted in 2005, it is strikingly clear that deposit return laws create a dramatic impact on the rates of PET recycling, increasing the percentage of bottle returns by as much as a factor of 3 times. This is confirmed by Finland's deposit return system, which had a return rate of 90% in the year of 2015. Simply put, when taking the easiest route hits us in the wallet, we seem to respond more responsibly. This is the first patent published relating to the chemical recycling of PET, assigned to Imperial Chemical Industries in 1948. The patent describes how PET could be broken down into very small monomeric units using glycolysis and then repolymerized, removing the excess glycol in a transesterification process. It also describes the formation and purification of bis hydroxyethyl terephthalate, or BHET. Today, we have a wide array of companies who are seeking to implement solutions to PET plastic pollution. First, what would happen if we simply dusted off that 1948 patent on glycolysis? Eastman, DuPont Teijin Films, and Ionica are 3 companies who are doing exactly that, using ethylene glycol glycolysis of PET to recover BHET. The beauty of glycolysis and several of these chemical recycling approaches is that when you convert PET into a liquid, by clipping the molecular weight smaller and smaller, the resulting low viscosity liquid can be filtered and treated more easily to eliminate contaminants than is possible by mechanical recycling. If the videos that have been published by Ionica are correct, then this company is also using a magnetic fluid, quote unquote, to remove dyes, pigments, and other impurities. The impurities cling to magnetic particles that are then gathered by an actual magnet, as shown in the third photo from the left, below in the reaction sequence. Meanwhile, Endorama is sponsoring the scale-up of Loop Industries' methanolysis process, where methanol is used instead of ethylene glycol. The resulting product in this case is dimethyl terephthalate. The very interesting and valuable aspect of Loop's technology is the fact that the entire process may be conducted at room temperature due to the presence of methylene chloride that swells the PET and accelerates the rate of reaction to about an hour, according to their patents. This represents a game-changing reduction in the usual energy input required by glycolysis or methanolysis, which usually requires, as you can see in the top reaction schematic, 200 degrees centigrade. Eastman has a long history of making polyester thermoplastics such as PET and claims to be pursuing methanolysis as well. BP has recently announced that it will be investing $25 million in a facility that produces terephthalic acid from PET in Naperville, Illinois, using its quote-unquote Infinia process. It is presumed that since terephthalic acid is produced, that saponification followed by acidification will be utilized, though BP does not appear to have described the technology in recent patents or press releases. Ionica's technology also claims to be able to produce this same monomer. Carbios, meanwhile, has identified a certain class of cutinase enzymes that can chemically depolymerize PET back to the diacid. Their process is also described as being capable of tolerating high levels of impurities, allowing them to use non-bottle sources of PET, such as waste textiles, fibers, carpet, strapping, film, and the like. This will provide them with an important cost reduction in their feedstock. This particular slide is near and dear to my heart because I've spent many years of my career participating in either the synthesis of PET polyols or polyurethane and PIR foams. So PET is also being chemically recycled on the scale of tens of millions of pounds via a process whereby glycolysis using glycols such as diethylene and triethylene glycol are employed as a first step, followed by esterification with fatty acids, vegetable oils, and other diacids as a second step. This process results in a liquid aromatic polyester polyol that can be formulated with catalysts, surfactants, and blowing agents, and then reacted with polymeric MDI to manufacture polyurethane and polyisocyanurate rigid foams for insulation applications such as laminated boards and spray foams. The companies that chemically recycle PET in this fashion include Huntsman, Coam, and Invista. The insulation remains in homes and buildings for decades, having not only the effect of mitigating plastic pollution, but also of reducing energy consumption as one of the best performing insulation products available commercially. EcoLoop and Eastman are taking a different approach than the depolymerization of PET. They're taking mixed plastic streams, including PET presumably, and gasifying them at high temperature and moderate pressures in the presence of steam to yield synthesis gas, also known as syngas. Synthesis gas is a mixture of carbon monoxide and hydrogen that may either be burned as a gaseous fuel or transformed into valuable chemicals such as polyethylene, methyl acetate, methanol, ethylene, acetic acid, gasoline, naphtha, and diesel. This approach is viewed as a route for recycling organic carbon rather than directly back to the original monomers from which the polymer came. Changing World Technologies, Braven Environmental, Encina, and Funix, in partnership with Dow Chemical, have all announced pyrolysis projects dedicated to converting mixed plastics into petroleum feedstocks such as naphtha, paraffin, liquefied petroleum gas, and BTX, which is benzene, toluene, and xylene mixtures. According to a McKinsey report entitled, quote, How Plastics Waste Recycling Could Transform the Chemical Industry, unquote, McKinsey's analysis suggests that, quote, reconverting plastics waste into cracker feedstocks that could displace naphtha or natural gas liquid demand, most likely using pyrolysis, may be economically viable and should be more resilient to lower oil prices, remaining stable down to about $50 a barrel, unquote. This is a very exciting possibility in that the raw material used for the front end of this process could be highly mixed and won't require extensive purification to remove paper and other contaminants, making it very cheap and versatile. Although this company does not manufacture or chemically recycle PET, I've included it because it represents a potentially game-changing technology. Algenesis produces polyesters that are based upon biorenewable content and that can also biodegrade when released into the environment. Not only does the technology reduce CO2 emissions, it helps to sequester CO2 already in the air. Algenesis is definitely a company to keep in your sights moving forward. To conclude, PET is a fantastic plastic that benefits our lives in many ways every day, to the tune of 123 billion pounds a year. Lack of municipal waste removal infrastructure in developing countries has promoted the use of rivers for this purpose instead, resulting in massive ocean pollution by plastic. Mechanical recycling is a proven route for redirecting PET away from landfills, but is mostly bottle-focused, thereby missing many other types of PET packaging and products. Deposit return programs have proven to increase rates of mechanical recycling. The U.S. average in 2005 was 35%, while in Michigan, where deposit return programs existed, it was above 90%. Large and startup chemical companies have commercialized or are pursuing glycolysis, methanolysis, saponification, and conversion of PET into aromatic polyester polyols, providing excellent options for turning the linear PET economy into circular PET economy. Gasification and pyrolysis show strong promise for recycling the carbon present in mixed plastics containing PET into valuable non-monomer chemical building blocks. Fermentation companies are emerging with exciting alternatives to PET that have demonstrated biodegradability in the environment. Please allow me to thank you for your time and attention, and best wishes to all.